Hi, are we on? Okay, I guess we are. Hi, everyone. Thank you so much for coming to this session. I'm happy to see you all. My name is Alina, and I'm here to talk with you about GraalVM and everything I can fit about it into 50 minutes. And I know that this is day 3 of the conference. It's the afternoon. We all must be tired by now. So let's see if we can make this session nice and chill, still educational, but maybe a bit more relaxed. That would be my plan. Let's go. A few words of intro. So this is my name, Alina, and this is how you can find me on pretty much any kind of social media. So if you want to ask any question, you have a follow-up comment, or if you want to ask me for a link for slides, demos, etc., you can find me on social media. And I'm a developer advocate for GraalVM at Oracle, and more specifically at Oracle Labs, which is the super cool R&D unit at Oracle, where we're doing a lot of research. And GraalVM has been such a research project at Oracle Labs for almost a decade. And I love open source and I love communities. That's why I like coming to conferences like this one and getting to talk to people in person. And I love both programming and natural languages. I do understand a little bit of Polish, well, quite well even. I don't speak any, but if you would like to test my knowledge, you can talk to me during the break. And this is my photo and again the name. So if you want to find me on social media, this is how you can do it. So let's talk about GraalVM, and before we do, if I could just see the room. So how many of you have tried building something with GraalVM already? Okay, quite a few people from what I can see. So maybe I can convince a few more of you to try something new after this session. So first things first, one thing that I need to remember about GraalVM is that it is a JDK, and we just add things on top of it. So like you would have Oracle JDK, OpenJDK, whatever is the JDK of your choice. GraalVM is a JDK just like that, and we pretty much don't remove anything from it. We just add things on top. So one thing that we have added is the GraalJIT compiler. Like in OpenJDK, you would have the C2 compiler. That is the top-tier, highly optimizing compiler. In GraalVM, we are replacing it with our own GraalJIT compiler developed by Oracle Labs. And the fun fact about it is that it's written itself in Java. So we like Java so much that we even wrote our own compiler in Java. That is one way how you can use GraalVM as a JDK with a different compiler. And by this transition to GraalVM as a JDK, you can expect somewhere around 10, 15% maybe performance improvement just by running your application in the JIT mode. But there is another big and interesting part of the GraalVM project, and that is what we will talk about here today, and that is the native image ahead of time compilation part, where you can take a Java application and compile it ahead of time into a native executable. And the reason to do so, it's because we will shift all of that kind of build and compilation work to build time, so you don't have to do it anymore at runtime every time you start your application. So yes, this is what makes GraalVM stand out from all other JDKs. It can do what any other JDK can do, and it still gives you that option of running your application on GraalVM as a JVM, but it also has this new way of running Java applications, and that is as native executables. And I really like showing this slide of our kind of project history and milestones because I think it's just a beautiful slide design, so I'm proud of our team's design efforts. But also there have been a lot of important milestones over the years that I would like to talk about, and I will not stop at all of them because it's a lot of information, but just a few things that I would like to highlight. So we started working on the project in 2011 when Thomas Wirtinger, my project lead, joined the team at Oracle. And then in 2019, we went GA. And also quite a while ago, in 2020, Alibaba, for example, started using GraalVM and native image in production. So it might seem to you like GraalVM is this new, revolutionary, groundbreaking kind of project, and it definitely is. I can see why you would feel this way. But also there are people and teams and companies who have been happily using native image in production for what, like 4 years now. And Alibaba, you can imagine the load there, so the amount of traffic and high load operations that they do at Alibaba. So if they are happy with native image in production under high load, I think all of us can be happy about it as well. And just another milestone that is dear to my heart. So we started working with the Sprint team on the integration in 2021. And yes, since then we got a lot of support from all other teams and frameworks. So let's talk about native image in more detail and how you can even take something so dynamic as a Java application that usually does a lot of things at runtime and compile it ahead of time into native image. So when you first run your native image command and you give it your application, and it has to be in the bytecode form, so your class files or your jar, what will happen is that native image will look at your application, starting from its main entry point, and it will try to find all the reachable code, so all the code that is actually involved in what your application is supposed to be doing, and then only put that code in that produced native executable and eliminate everything else. And this applies to your application code, so the code that you actually wrote, but also even to your dependencies, your JDK classes, pretty much everything that is involved in your application. So it will put everything there is to be used at runtime into the native executable and eliminate everything else. Just so at runtime, there is a more kind of minimal, stripped-down version of your application, and there is no longer JVM and Jet compiler at runtime anymore. So that is one part of the story, and often people call native image ahead-of-time compilation, and it's definitely true, but there is another big part of the story, and that is, as we are performing this analysis, we'll also look at your heap of your Java application, and we will see what is safe to kind of snapshot from your heap, and then we will also prepare a heap snapshot, so you can start much faster at runtime with this pre-populated heap. And in the end, what you have is your native executable with your machine code and your pre-populated heap. And that native executable is platform-specific, and that is something that we will get to later on in the presentation. And usually at this point, I keep talking about native image and why this is something you might want to use. But I figured maybe we can start with a demo. We can take a look at it, and then we can talk about the benefits and why you would do it. So let's go ahead and see the project. And I'm sorry, I will not be doing a light theme because it gives me PTSD. But I did maximum zoom, so I hope this should be visible even in the rows in the back. So what we will start with is the Spring application. And here is my main application class. So we can see that this is a Spring app. And we have a bunch of things in there, but the one that we are kind of most interested in is this hello controller that will expose an endpoint and return our message on that endpoint. So let's go ahead and see if we can run it. Let me just remove some of this stuff, and let me clear this. And let's check what is our Java version that we are on. And we are on Oracle GraalVM for Java 22, so the latest, greatest released version of Oracle GraalVM. So let's go ahead and run it. And I told you that this is a normal Java, right? So we can run our application as we would on the JVM. So Maven Spring Boot run. And let me see if I can do my keyboard light so I can see anything at all on this stage because of the lights. No, that is not the one. OK, I guess this will have to do. Anyway, so our application is on. It started in something like 1 second. So let's go ahead and check it out. For that, let's go here, localhost, hello. And we get our message. So not rocket science, but it does work, right? So let's go ahead and see how we can make this application native with GraalVM. Let's clear all of this. And let's compile it now live, because why not, right? So Maven p native compile. And this will now start a native image build. So it will ahead of time compile everything that there is in my project into this native executable. And this is a part where some people start losing patience, especially if you have a bigger application that has a lot of classes, a lot of dependencies, a lot of stuff going on. So sometimes they would complain to me, this application build takes a few minutes. I don't have such attention span. But for what native image is doing, it's actually impressive how fast it is. Because even if you look at my minimal application, it will now analyze application and tell me what it found in it. So for example, even if my minimal app that you've seen had just a few classes, but also dependencies, so the Spring Framework, etc. So even my minimal app has 25, almost 26K reachable fields and almost 90,000 methods, which is insane. And even that is just a fraction of the whole app. So that is what's involved in my application's workload, basically, but the actual project is much bigger. So I would say compilation times of 45 seconds, that is quite OK for fully compiled Spring Boot native app. And if we take a look at what we made happen now, so exa target, here is my demo, freshly recompiled just now, and the whole size is 64 megabytes. So let's go ahead and run it. OK, now it starts in 48 milliseconds. And if you go to our endpoint, it does the exact same thing. So it is still working. OK, so far so good, but you could be telling me, application startup, it's one metric. Maybe I don't care about it that much. Maybe I have a larger application that I build and deploy, and then I run it for hours, weeks, and I don't care about its startup time that much. And I agree with you that it's not the most important thing you could be caring about. So let's see how our application performs in other aspects. For that, I will do some quick and dirty benchmarking. Let me show you what we'll actually do. So here is my first benchmarking setup. This will be running on the JVM. So you see I'm doing Java, and I'm turning off the GraalJIT compiler because I want to get back just my normal C2 JIT. I'm running my jar, and then I'm using the tool called PSRecord to output nice graphical chart of how many resources my application is consuming at runtime. And then we will use the tool called Hey to send the load to our app. And we will even try to do proper warm-up by splitting our 500,000 requests into 2 batches. One will be warm-up load, and the other one will be actual benchmarking load. So this is probably giving my friend here, Nitsan, a stroke of how unscientific this is. But I would say that for a conference session, this is decent enough benchmarking setup. So let's go ahead and run this. Bench JIT. This will now start the app. So we are actually even waiting for 2 seconds. And then we will send warm-up load and benchmarking load, and we will compare the numbers. So we've seen the output of Hey for the warm-up load. We will now also got the benchmark load numbers. And the numbers are, and I'm also interested in peak throughput, so let's see what they are like. So here my peak throughput request per second is 45K in the warm-up run. And then in the actual benchmarking run, it's 55K. I would say it did warm up quite a bit. That is impressive. So maybe this is fast, maybe it's not. We will not see until we compare with native and see how we can do. For that, let me just check my native benchmarking script and see what we are doing here. So the memory is still the same because I'm changing this number. So this is all good. And the exact same load. So now let's run the same thing on the native image and compare the performance. But before I do, let me ask you, so who thinks the native app will be faster than the JVM app? OK, not a lot of optimistic people. Well, you know that I'm working on GraalVM, so I could have tuned the numbers to make it look good, right? But let's see. So let's clear this, and let's run our native script. So this will now do the same load against the native app. And this color was supposed to be purple to distinguish between the 2 modes, but I would say it is more pink than it is purple. But let's see. So this is all done. Let's see our native warm-up run. Where is it? Here. So this is already at 50K requests per second. So there is, I would say this is comparable with the warmed-up JVM. Slightly less, maybe what, like 5–10%, but still comparable. And the second run is, yeah, this is my second run, 50K. So I would say slightly below the JVM, but still comparable. And there is no warm-up curve. So it's already available from the very first milliseconds. And it does you comparable performance with the JVM. So the next time somebody tells you that you cannot have native Java application performing as well as on the JVM, you can tell them that it's possible if you know how to optimize it. But I can take it even further and do one more interesting experiment by going here to my native script and seeing what happens if I give my app less memory. So I'm splitting the memory in half, and let's see how that will affect our application. So let's just run this again. Bench native. OK, it will do the same thing again. Warm-up run and benchmark run, only now we only have the fraction of memory. So let's see how our application performs with just the half of the memory. OK, all done. And our numbers, they got like 1K requests per second lower, but still comparable. So 2 things that you can do here, as you can see on this example. So one thing, you can run the same application with half of the memory that you will give to the JVM, and you would still have comparable peak throughput. Or if you want to, it's a bit more complicated, but you can deploy even 2 such instances of the native app for the memory footprint that you would give to the JVM. And this way, with a little extra work, you can have double the throughput of the memory, double the throughput of what you have when you run this app on the JVM. So you definitely can have good performance with the native application as well. And the last demo in this section, the presentation that I want to show to you, is I want to show you a native Spring AI demo. I'm wondering if any one of you who have tried using Spring AI already. I don't think I see any hands, but also this is still an experimental kind of work in progress project. So let us see how we can make it work. Let's clear this, and let's take a look at our app. So what I have here is a little travel recommendation application that is, again, a Spring app. And what I want to do is I want to build a travel recommendation service where, as a user, I can input where I want to travel, what kind of activity I feel like doing, and what is the mood that I'm in. And then we will go ahead and talk to the OpenAI API to get a recommendation for travel for our user. And this is using OpenAI and GPT-4, but not only GPT-4, but GPT-4.0, so the latest and the greatest, just recently released version of GPT-4. And of course, I already have this compiled as a native image, so let's see. So, we are still in the previous folder, so let's go ahead to the native Spring. OK, again, maybe we can just do this. Yes, so here's my travel app, and it's slightly bigger than the previous one. So it's 111 megabytes, but it's my complete application with the front end and everything that it needs. So let's go ahead and run this. And it started fairly fast, I would say, again, in 56 milliseconds. So let's go ahead and check out our app, and it's just at localhost. So this is my travel recommendation app. And can we stop for a second and admire this beautiful front end that I created myself? It might not look like a lot, but I promise you it looks much better than it did in the first iteration. So let's go ahead and get some travel recommendations. Let's say we want to travel to Switzerland. And let's say we want to do hiking. I really don't want to, but you kind of have to if you're going to Switzerland. And let's say we are in the adventurous mood. So what will be the result? OK, I'm not sure I can read it, but let me give it a try. So I recommend you visit the Lauterbrunnen Valley in Switzerland. Perfect for adventurous hikers, blah, blah, blah. 72 waterfalls. OK, I guess it's a good enough travel recommendation. But just to verify that our application is indeed working live and there is no kind of backed-in data and magic, let's do something else. So let's say this time we are traveling to Poland. And we don't want to do hiking anymore, so maybe we want to do cocktails. And let's say we still feel adventurous, so where would we go this time? OK, I highly recommend visiting Krakow. I guess we're in the right city. So apparently, it's a vibrant city that offers a mix of historical charm and modern attractions. So yes, I hope by this time you believe me that we can indeed build such cool applications with GraalVM. They can be native and have all the capabilities of native apps in terms of performance, but also you can use all the coolest and bleeding edge libraries out there. With that, let me stop this, and let me go back to my slides. So what we see before here is that you can indeed build an application with GraalVM native image that will start very fast. We saw it 50, 40 milliseconds, and they are very fast indeed. But that's not the only benefit. And we also looked at the resources usage, and we see that if you're building such an application with GraalVM, you can use much less memory than you would normally on the JVM. So on average, what we see is an application, when it's run as a native image, will use around 3x, 5x less memory than on the JVM, because all that work the JVM does normally at runtime, so for example, loading your classes, analyzing, compiling, profiling, etc., we give you a trade-off where you can shift all that work towards the build time. So you can build your application once, and then you can start it much faster every single time you need to start it, because that work already has been done. And we think it's a reasonable trade-off and a reasonable thing to do, because many applications are started way more often than they are built. So it makes sense to do all that work once and don't repeat it every single time as your application runs, especially when it runs and the JVM is also, in a way, competing for the resources of the machine with your application. So you can use fewer resources. You can reduce your cloud build this way, especially when it comes to memory. And you can just, be a good citizen, help the planet, use fewer resources, have greener Java applications with native image. But we also saw that native image has a bit more predictable performance in terms of how it behaves over time. So unlike on the JVM, if you were to imagine peak throughput as a chart, there are fewer fluctuations because it's all native code and it's less affected by all the things that are happening in the JVM in runtime. So if you want to have more predictable performance over time and also more predictable consumption of resources, that is something definitely that native image can give you. And another interesting part of native image, and I think this is not talked about enough, so I like talking about this a lot, is improved security. So we kind of add additional security layer on top of the JVM, and that is coming one way from the fact that I mentioned above, and that is that native image is eliminating all the code that you are not using. So it's looking at your app, it's looking at all the dependencies, and if you're not using something, it will not be included in the native executable. And this way, we, for example, are reducing the attack surface because there are just fewer things to attack at runtime. Also, the way native image works is that it composes the application ahead of time under closed world assumption. And this means that things like reflection and serialization just not possible in native image unless you configure them with specific allow lists. And one more benefit of native image is we saw that those binaries that I have produced were much smaller than application running on the JVM. So if I were to run my application on the JVM, and let's say it's the same Spring Boot application, it will be maybe the whole jar 200, 300 megabytes, but native image is much smaller. So 30, 40 megabytes, and this is the sizes of your whole application. And we saw the demo of Spring Boot application, but I see my colleagues here from the Micronaut in the room. So in 2024, we have a lot of support from different frameworks and libraries. So it's very easy to build applications with GraalVM native image in 2024 in terms of libraries, frameworks, and cloud vendors. So I mentioned the libraries, and I often get this question of which libraries work with GraalVM. And for that, let's go to one page that I want to show you on our website. So I mentioned that native image works under closed world assumption, and that means that things like reflection and serialization, they are possible in native image, but they require a specific allow list. And that list can be coming from yourself as a user, but also library or framework. And this might be seen as a limitation, but I think it's just a different programming model, and it gives you more control and more awareness over what is happening in your application. So if you want those things to enable, it's definitely possible in native image, but it just requires a little extra work and kind of a hint from a library, framework, or you as a user. So if you want to evaluate which libraries and frameworks work with GraalVM and native image, you can go to this page on our website that is called Ready for Native Image. And there you will find a very long list of tools, libraries, and frameworks that already work with native image. And this is, I would say, a minimal list, so list of things that are contributed by the community and known to be working and testing with GraalVM native image, but the actual list might be much larger. Those are just things that we know and reported by community to work. So I want to mention a few more things about libraries and those more dynamic Java features. And this is going to escalate a bit, so I apologize for that. But if you want to build application with GraalVM native image, this is important to know. So I want to stop here and talk about all the different things that libraries and dynamic features of Java can work with GraalVM and native image. So this is not a list of all bullet points that need to happen, but this is rather going from the best case scenario to a scenario where you need to put a little bit more work to make something work with GraalVM. So first of all, a library can work with GraalVM native image out of the box, just by the way that it's written. And it can be friendly towards GraalVM native image. So for example, use less reflection, or maybe use reflection in a way that is more obvious to GraalVM native image. So this is the best case scenario. And lately, we see a lot of libraries just appearing this way, where they are friendly towards GraalVM and native image out of the box. Now, if that's not the case, if a library existed before native image happened, it can provide configuration for GraalVM and native image to make it work. And I would like to illustrate that point by looking at the H2 library. So in the past, I used to show a demo where I had a library, an application using H2 as a library, and it wouldn't work, and then I would make it work. But right now, it's just not needed, because if you look at H2 and its source code, there you can find this reflect config file, which tells native image, hey, please make those things visible as you are building the image. So please build an application that is aware of those reflection calls inside our library. So if you want to build a library with, for example, H2, it will just work out of the box because they're providing this config. So that is one case, the next good point. And the one more point that is still in this kind of happy past scenario, but also most of the libraries that I think you will be using right now in 2024. And the next good way of how library can work with GraalVM native image is that you would think that, for example, if a library is using reflection, serialization, etc., and you figure that out as a user, there should be a way to share this kind of knowledge and configuration with other users. And indeed, there is such a way. So we have created this repository on GitHub where users, maintainers, library authors can create and contribute config for popular libraries. And then we have our native build tools, so Maven and Gradle plugin coming from the GraalVM team. And those will automatically pull config from this place. So for example, we have some config there for Netty. So if you are using Netty and you are using our Maven and Gradle plugins, they will just discover this in your application's build file. They will go to GitHub and pull the config. So this way, the library will just work for you. And again, those three first bullets is, I think, what you will face most of the time. So just for your awareness, this is how libraries work with GraalVM. But this is where things just work for you out of the box and no configuration needed from your side. Now, it can be that you want to use some library that is not friendly towards native image yet. So what do you do in that time? If you're using one of the frameworks that works with GraalVM, and that is Micronaut, Spring Boot, Halidon, Quarkus, most of them offer you some kind of API, annotations, etc., where you can say, hey, I want to make this work with GraalVM native image, and I know that this is, for example, a reflection call, or I want to access some resource at runtime. Can you please generate hints for native image? So native image can discover this and include this in the build time. So by using those API, you can have a programmatic way to create configuration for GraalVM and native image. That's one good way. Now, if you're on a version of a framework, maybe that is not friendly towards GraalVM yet, or if you have some code that you wrote by yourself, some maybe internal custom library, the best recommendation that I can give is to use the tracing agent that is inside GraalVM and inside native image. And the way this works is that you will run your application on the JVM with the agent attached to it, and you need to emulate kind of production behavior. So let's say I want to access and read some resource at runtime. I would need to run my application on the JVM with the agent, read that resource, and the agent will look at that call, and it will produce this config file for me and make those available to native image automatically. So that's another good way to make things happen. And the last way, and I hope this is something you will never have to do, is that you can write those JSON files like the one that we've seen in the H2 repo yourself. But writing JSON files, it's not something very exciting, so I hope you will never get to that. And I hope this was not too complicated and kind of made sense. But if you want to use libraries with native image and you have some, I don't know, questions or challenges, I hope that this slide answers them. Now, I do want to mention a few words about testing and, in general, like good practices when working with GraalVM and native image. So if you look at your framework, usually there is some kind of support for testing with GraalVM and native image. For example, there is JUnit support for GraalVM native image. And if you look at the frameworks and what they will offer you some kind of module for working with GraalVM and native image. And even for integration testing, for example, in Micronaut, there is this module called Micronaut Test Resources, where you can test against external dependencies, including in the native image mode, by leveraging test containers underneath. So if you want to test your application in the native image mode, my general recommendation is that you just keep developing and testing and building your application on the JVM, and then you compile to native once in a while, or maybe in your CI/CD, or maybe if you're introducing a new dependency, but this is not something that you have to do all the time. So you don't need to recompile all the time as you are building your application, because this is just, I would say, waste of your time and resources. So usually things just work, and then you want to make sure as you are building your app towards the deployment, or if you're introducing a new dependency. But overall, you just develop your application on the JVM. Now, let's talk about performance. And we've seen some demos, but I want to illustrate this point with a more kind of meaningful application, and that is the Spring Pet Clinic application. That is a good metric and a good way to talk about performance of more like enterprisey, higher scale application where you would have your database access, reading data, writing down data, and talking to different endpoints, etc. So here you can see that with native image, you can have performance that is on par with the JVM. And I know that this is a bit hard to process and hard to believe in, but there are some additional optimizations in native image that are just not available on the JVM. So with those additional optimizations, you can have performance on par or even better than the JVM, in addition to what I mentioned before, so small startup, low memory usage, small packaging, etc. And we like to talk about resources usage and, for example, memory efficiency. So this chart, it takes a while to process, but stay with me. So here we are mapping operations per gigabyte per second, so how much throughput you can get with the given amount of resources and time, and how does that change over time if you are giving your application more memory. And I have two observations here. So one, if you see the native image orange line, that is consistently over the C2, so let's say OpenJDK line. So no matter how big or small your application is, you will usually get more kind of throughput per resources as you would on the JVM. And one observation that I have here is for an application that is, let's say, smaller or mid-sized heaps, so maybe 512, 1 gig, you would get even 2x efficiency of your resources usage when it comes to throughput as you would on the JVM. And even if you want to have good latency metrics, maybe you have some kind of SLA agreement with your customers, even that is possible with native image, and more specifically if you are using the G1 GC. OK, and how do you go about building your app? What are some good practices that I can recommend to you? So when it comes to packaging, I briefly mentioned that our applications can be very small, and we've seen that on the example of Spring applications, where we can take it down to 40 megabytes, maybe 100 for a larger app. When it comes to containers, if you want to have a very small, minimal container image, here this is on the example of a Spring JDK simple web server. And if you want to have the smallest possible container image, you can do what we call static native images, where it's fully static linked. And then you can deploy it in a very minimal Docker image, and that will be very small. For example, here the size of the image can be as low as 18 megabytes. And building applications, there is one more good tip that I can recommend to you. So I mentioned that those native executables are platform specific. So let's say if I'm building it on my Mac, I cannot deploy it on a Linux machine or even on the Intel Mac, so they are very specific to the operating system and platform. But there are good ways around this, and one such good way is CI/CD systems. So I like GitHub Actions a lot, and we also have our own GitHub Action, and this way you can set up builds, for example, for all the different platforms that you want. And when it comes to the resources usage, I don't know if you paid attention in the demo, but as I was building my app, you could have seen that the application was taking about, I would say, 2 gigs of memory for each of the build steps. So right now, GitHub has very good runners, so you can even build larger applications on GitHub Actions, and basically for free, and just produce them for all the platforms you might need. So for deployment, I think CI/CD systems, and more specifically GitHub Actions, are a very good way to go. And if you want to take maybe like one photo of the slides that I was showing here today, I would say that this would be the slide. So if you want to go and check out GraalVM native image, what are the good recommendations that I would give you? Or maybe you want to migrate your existing application. So one thing I would suggest is you add other native build tools, and that is especially if you are using maybe an older version of frameworks or a framework where there is no support for GraalVM yet. And those native build tools are Maven and Gradle plugins that will help you build applications, test them, and also pull configuration for all those libraries and frameworks. Now, for building and deployment, you can build the application on the JVM, so you can have like a faster feedback cycle. And there is one small tip, but one that I like a lot. And that is if you are still building your application and you need to recompile it a lot to see that something still works or doesn't work, I would use this -OB flag. And this enables quick build mode, where you can get much faster build times for your native image applications. They will not be like 2 or 3 times faster, but 20, 25% faster. That's still good as you're developing your application. And then there is a bunch of optimizations that you can use to get that performance like I've shown you on par with the JVM. So one such optimization is PGO, where you would build an instrumented version of your application, and then you can run it, collect profiles, and then feed those profiles back into the native image as you're building your app. So this way, native image can build an application that is aware of runtime behavior of your application and optimize for specifically those use cases and scenarios that will happen at runtime. And this is kind of similar to how the JVM profiles your app, and we all know the JVM is very good at profiling, but in a way, it's maybe even cooler than on the JVM, because JVM spends a lot of that profiling time as your application just starts and warm up, and native image profiles your whole application, so in a way, it can be even more powerful than the profiling that the JVM does. Now, if you think that this is too complicated, so you want to build the instrumented binary, then run it again, then compile it again, in case you don't want to do it, out of the box, we have something called ML-enabled PGO. And that is when we would use ML to look at your application and predict what it's supposed to be doing at runtime. And we will build an application that is using those predictions and optimizing for those scenarios that we predicted. It's not as powerful and precise as profiles provided by you manually, but this will give you maybe 6–8% performance improvement out of the box, comparing to not having any profiles available at all. And another good tip, there could be different GC strategies, but if you want to have peak throughput specifically, I would recommend checking out G1 GC to optimize for that. And the last helpful flag here, if I know that I will be running my application on the same machine that I'm building that, I would say mark native, and that instructs native image to build an app that will be using the specific hardware features of this machine rather than target for compatibility. OK. And let's talk about what is next for GraalVM. So recently, we had our new GraalVM for JDK 22 release. So in general, we release on the same dates as the JDK community. So every time you have a new Java release, you also have a new GraalVM release. And there were a lot of cool features and support for also latest Java features in this release. And for that, I want to show you one more demo. So this is a demo that I'm borrowing from my colleague, Nikolai Parlog. Do you know Nikolai? I'm sure everyone knows Nikolai. OK, more or less everyone. So this is called Modern Java in Action. And this is his demo that is a little GitHub crawler, where you would run your app, you would give it a GitHub URL, and it will go to GitHub and crawl that page, find all the URLs, and qualify them, like what kind of URL that is, and it will output the little report for you. And this is using, of course, all the latest Java features, so virtual threads, pattern matching, web server, etc. So I have a little fork of this application, and I basically made just one small change to it. So I added native Maven plugin. So this is what I'm calling native build tools, and this is the first step that I would do to migrate any kind of application to native image. And basically what I'm doing here is I'm saying enable preview. So this is the flag you would use on the JVM, and it's the same on native image. If I want to use preview features, I need to enable them explicitly. And I'm passing my preferred binary name. But this is pretty much all I did to make this application native. So let's go ahead and check it out and see if we can run it. OK, let's see. So this is my target directory. And I have my native modern Java executable. So the whole file is 37 megabytes. So let's run it. And it's a GitHub crawler, right? So we need to give it the page that we want to crawl. So let's maybe do this one, layered native images. This is an epic that we are working on GitHub. So let's do this. And let's specify our preferred crawl depths. And I hope I haven't abused the GitHub API today too much yet. No, all good. And it's also put up a little web server for me. So let's go ahead here, localhost 8080. And now we can also appreciate Nikolai's front-end skills as well. So this is the result of our crawl. So this is running, fully functional, fully working, using all the latest Java features, and running as this small, self-contained native executable. So that is pretty cool, and we're trying to keep up with the latest Java releases and the latest released features, and make sure that you can use all the latest Java features together with the GraalVM features. Yeah, that was the demo, and I want to talk to you about two big projects that we are working on in the GraalVM team, like epics that we are working on. So one is called Layered Native Images, and this is something we are very proud of, but it's a big project, so it will take a while to happen. So if you ever try to compile a larger application with native image, you might have noticed that it takes maybe, I don't know, minutes, and not everyone has that kind of attention span, and we understand that. So we are working on a way to give you an opportunity to build your images in a layered fashion, kind of like Docker images. So let's say I have my Spring, Micronaut, whatever application, and I want to use some dependencies from that framework, and I obviously have my JDK dependencies, and I have my application code. So maybe I can once compile my JDK base, my Micronaut base, and then every time I'm introducing changes to my application code, I would only recompile what I wrote, so my application code, this thin layer, and those base images, they can stay compiled, kind of like shared libraries, not exactly, but like shared libraries. So every time I'm recompiling my application, I'm only recompiling my own application code, and the rest stays the same. This way, we think we can take compilation times down to seconds, similar to what you have on the JVM, because the rest stays compiled. So this is clearly great for developer experience, but we see one more possible benefit, and that is once you deploy your application, for example, to the cloud, and let's say I want to have 5 instances of my application, they can, again, reshare those base layers. So let's say I have 5 instances of my Spring app, and I have my JDK base, my Spring base, my Spring web. So my instances can reshare those base images in the cloud, and this way reduce the resources usage even further. So this is something we are working on, but it's a big project, as you can tell, so it will take a while to make happen. But I've seen some prototypes already, and they look very promising. So fingers crossed that maybe with the next release or the release after that, we can see some tangible results that we can actually go ahead and try. And one more big project that we are working on is called GraalOS. I don't know about you, but I like the name. Kind of like GraalOS. It's not an operating system, really, but it's a deployment platform where we want to give you an opportunity to deploy applications as native images rather than containers. And this way, we think we can eliminate that little overhead that containers still have. But also, we think this will be still better developer experience because you will deploy your native executable, and then we will take care of things like memory usage, resources sharing, security, scalability, everything for you. So again, big project, but we are working on it, so hopefully we can share more updates soon. So to summarize why you would be looking into GraalVM and native image, there is a bunch of benefits. Don't listen to people who tell you that native image is all about startup. It's not. As you've seen, it also gives you better resources usage, more predictable performance, and also what's important, performance on par with the JVM. You can have better security, and you can have smaller packaging. And we have this big vision where we can give you performance in terms of peak throughput on par with the JVM, so you can maximize every possible performance metric with GraalVM and native image. So if you want to get started with GraalVM, so hopefully I convinced you to go ahead and check out some of those things for yourself. Those are just a few resources that I would like to share with you. So our website, you can pull container images. You can use SDK-man to use GraalVM. And I encourage you to use SDK-man. It's really great and easy to use. And we have a bunch of demos on GitHub if you want to try out things for yourself. So if you want to ask me a question or stay connected or check out the demos that I have shown today, here are 2 QR codes that will help you make that happen. I see people are taking photos, so I will give another second. And that is all. Thank you. And let's take a look at questions. So let me see if I got the page right. How do I do the big QR code thing? But I guess you got it, so it's all good. OK, let's see. Does GraalVM 21 Plus support virtual threads? If yes, how do they work in a native app? Great question. Thank you. GraalVM does support virtual threads ever since GraalVM JDK 21, and obviously in 22 as well. And I've been told by my team that we have a very good, highly competitive, highly performant virtual threads implementation. We even have some benchmarks where on native image, virtual threads perform even better than the JVM. So I think it's a very good question. Thank you for asking me that. Give it a try, and I'm sure you will like it. Is the native image compilation in free GraalVM license? Let's split the license question into 2 topics. So I should have mentioned that in the session probably, but GraalVM does come into 2 editions. We have an open source edition that is full open source, available on GitHub, etc., and that is called GraalVM CE, Community Edition. And then we have what is called Oracle GraalVM, that is licensed under GFTC license. So if you know Oracle's NFTC license for Oracle JDK, that's a very similar license that enables free usage in production, but go ahead, check the license. I'm not supposed to comment on things like that. Long story short, you can use native image in both editions, so Community Edition and Oracle GraalVM, obviously for free. And as long as you're using this in production in compliance with the license, you will be good no matter which license you're using, open source or Oracle GraalVM. Can GraalVM become the future of use in commercial Java, well, I guess, usage applications? Well, I certainly hope so. And as I said, we have this big vision where GraalVM can give you performance on par with the JVM. So, and sometimes when I'm at conferences, I'm getting this kind of tricky questions. So, like, when should I not use GraalVM? And my answer is always use GraalVM, but define which part of GraalVM works best for your project. So you can use GraalVM as a JDK, and this is why you still run your application on the JVM, but have better performance coming from the Graal compiler. Or if you want startup, resources usage, packaging, etc., you can use the native image, but really GraalVM gives you the power to use whatever mode works best for you. Any large server apps using native image. So I don't have specific numbers from Alibaba about how big their application is, but I would argue it's super big because I've seen their benchmarks, and the application that they moved to native image used to start in, I think, how much was it? I think 60 seconds on the JVM was the startup time, and they took it down to 3 seconds on native image. So I can only imagine the scale of that app, and it must be really huge. So I would say yes. How will not native app version perform with 1 second of memory? I tried this a little bit before the conference, so maybe earlier this week. I think the performance dropped down maybe by half in my measurements. But if you're curious, you can come to me afterwards. We will rerun the script with the JVM and just halve the memory. I would bet it will be maybe like half of the throughput. Is ZGC, Jan ZGC supported on Graal? That's a good question. So Graal JIT does support ZGC, not the Jan ZGC yet, but I've been told that this might happen for the next release, so fingers crossed. And when it comes to native image, the recommended option that I will give to you is G1GC. We don't have ZGC support in native image just yet. Can I share the slides? Yes, I can share the slides. How GraalVM deals with third-party dependencies with closed licenses? Well, I would say the licenses question is up to you. So I don't think it influences the license of the dependency. So if you're OK with using the license, and the license allows you to pull it into the project and then, let's say, distribute it, then technically there is no issue with that. But license-wise, I would recommend reading super carefully the license of that dependency. Did you use PGO in your demos? The one where I was doing performance testing against the JVM, I did use PGO, yes. Is it possible to create a native image of a library and then link to a native image of an application? I'm not the biggest specialist on linking. I know that it's possible to do shared libraries, and I know that it's possible to do multiple ways of linking, so fully static, dynamic linking, etc. So I would guess then yes, but I would recommend that you try it out yourself. Is it much harder to debug native than the JVM? It is a bit harder, I'll give you that. So at the moment, you would debug your application using GDB. And we understand this is not ideal, so we are working on a JVM-like debugging for native image, and I hope this will land in the next release, maybe the release after that. Is there a way to shrink down the image size? My app takes 45 megabytes. I think it's too much. I don't think it's too much, 45 megabytes for a Java app. But funny you should ask, there is this tool called UPX that is kind of a compressor tool for native executables. And you can compress your native image with UPX. It will be much smaller, definitely. But be aware that if you compress it much more, it will have an impact on runtime. So if you're compressing it too aggressively, it might be slower at runtime because it will need to decompress, basically. What about Truffle project? I'm glad there are Truffle fans in the room. Truffle project is doing great. Truffle is the language implementation framework on top of GraalVM, so you can implement your own languages on GraalVM. We implemented ourselves JavaScript, Python, Ruby, etc. And yeah, it's doing great. It's now being decoupled from GraalVM, so you can use it on any other JDK of your choice. That's pretty cool. And funny update about Truffle, since you mentioned it. Last week, I saw a C# implementation on Truffle, which somebody did for fun. So you can also run C# on Truffle and GraalVM. With that, I think I'm exactly out of the time. If you have any more questions, please come to me, and I'll be happy to answer them. Thank you so much.